Hello everyone and welcome to Kiru's online lectures. I am Kira Jamdani and today's topic is trigonometric functions part 3. See, in part 1 we already discussed about the introduction and measurements of angles. In part 2 we studied about trigonometric functions. Now in this part we are going to study the graph of trigonometric functions. Coming on to first graph, y is equals to sin x. Now as we know, if you are talking about trigonometric functions, that means it is something related to the function which we studied in our previous videos. So whenever we are talking about functions, we should know about the domain and range. So now coming on to the first trigonometric function, that is the sin y is equals to sin x. So if we look over here, the graph of y is equals to sin x, we can see domain. Now what is basically domain? Domain is basically all permissible inputs. Now as we see over here, the value of x is 0, value of x is pi, then 2 pi, then 3 pi, then 4 pi. Similarly over here minus pi, minus 2 pi, minus 3 pi, minus 4 pi. So domain is, if we look over here, domain is, if we can see, that is set of all real numbers. That is, these are the inputs which we made, that is x is equals to this. So what will be the value of y? So whatever y will come, that is the output results, that is what range. So as we see, if x 0, so that is y is equals to sin 0, so we will get y to be 0. But if x is pi by 2, so y is equals to 1. The maximum value is coming out to be 1. Then again, if it is pi, so x is 0. X is pi, so y is 0. Similarly over here, that means we can see beyond 1 the value of y is not coming, and below minus 1 also value of y is not coming. So range will be minus 1 to 1, where minus 1 and 1 both are included. Now as we see in this graph, this curve, like this curve, it is repeating. So it is repeating, the same curve is followed after 2 pi. That means this curve repeats after the interval of 2 pi. So thus we say sin x repeats its value after interval of sin 2 pi. Let's suppose if I am saying sin 2 pi, if sin 2 pi is 0, sin 4 pi is 0. So is the case with everything. So this is how we have to study this graph. Thus we can say sin 2 pi plus x, because this sin x repeats its value after 2 pi interval. So sin 2 pi plus x is what? It is sin x. So this was all about the first trigonometric function, that is sin x. Moving on to next trigonometric function, which is cos x. Now as you see over here, you can say the domain. Domain is again, as we see, x0, pi, 2 pi, 3 pi, 4 pi. So domain is again here the same thing, that is set of all real numbers. Range, it is also same, that is all values, it is also beyond 1 it is not going, and below 1 also it is not going. Range is what? Minus 1 to 1. Now if you look over this graph, so this graph is basically repeating like this. So it is also repeated after the interval of 2 pi only, or we can start from here. This is pi, this graph is also repeating after the interval of 2 pi. Only the difference between the sin x and cos x graph is that when x is equals to 0 over here in cos x, the value of y comes to be 1. But in sin x, when x is 0, the value of y is 0 only. So this graph, that is cos x graph, also repeats its value after the interval of 2 pi. Thus we can say cos 2 pi plus x is also cos x. Coming on to next graph, which is y is equals to tan x. Now as we know, y is what? Sin x by cos x. Now for cos x, we know if cos x becomes 0 over here, if cos x is 0, that means we'll get y is equals to sin x by 0. That means this value will be not defined. But if sin x is 0, so y becomes 0 and this value is still defined. So domain will be domain will be for all the values except where cos x is 0. And we know, when we are talking about domain, we know x such that x belongs to R and x should not be equal to 2n plus 1 pi by 2. So this is our domain. Now coming on to range. So if we see range, we are getting all values. These all values we are getting, as we can see the graph. So range is what? It is set of all real numbers. Now if you see over here in this graph, these values, these curve, like this curve is there, then this curve. So this curve is repeating after the interval of pi. So then we can say tan of pi plus x is what? Tan x. So this is about the graph of tan x. As we can see over here, this x is 0. So the value of y is also 0, because if x is 0, so 0 by 0, the value of y will become to 0. So this is how we can find out the graph. We can draw graph. Now next graph is y is equals to cot x. Now this graph and the previous graph, that is tan x, was similar. Only the difference is that cot x is cos x by sin x. So here for sin x, if sin x comes out to be 0, then this y is equals to cot x is not defined for sin x equals 0. So here domain will come out to be x such that x belongs to all real numbers except where x is equal to n pi. Now, or we can say x is not equal to n pi. But if you see over here the outputs, you are getting all values. As we can see the curve over here, all values we are getting. So range for this function will be set of all real numbers. Now this function is also repeating, as you can see, after the interval of pi only. See this 0, pi by 2. Then after the interval of pi, the same curve is repeated. So that means this curve also repeats after the interval of pi. So we can write cot pi plus x is equals to cot x. The next graph is y is equals to sec x. The next trigonometric function, that is sec x. Now as we know, sec x is the reciprocal of cos x. So y is equals to 1 by cos x. So here when cos x is equals to 0, this y is not defined. So therefore we can see the curves are like this. Because when x is equals to 0, this curve is not defined. So domain again here will be what? X such that x belongs to R and x is not equal to 2n plus 1 pi by 2. So this is what? Domain. And now if we see over here the range, see, above 1 we are getting all values, but this value we are not getting over in our graph. Below 1 we are getting all values, but this value we are not getting. So range will come out to be y such that y belongs to real number, where y is less than minus 1 or y is greater or equals to 1. So this is what the range for this particular function. Now as we see over here, this value is again repeated after the interval of 2 pi. That means sec x value is also repeating after the interval of 2 pi. So we can write sec 2 pi plus x is equals to sec x. Next graph is y is equals to cos sec x. If we see over here this graph, again it is same like the sin x, like the sec x. Difference is that over here we have 1 by sin x So here sin x is equals to 0, not defined. When sin x is 0, so y will be not defined. So domain will come out to be x such that x, where x belongs to all real numbers and x is not equal to n pi. That means all values except where sin x is equals to 0, this is not defined. Now if we see over here range, so range again it's same like the sec x, y greater than 1, y less than or equals to minus 1. So it will be y such that y belongs to R, where y is greater or equals to 1 or y is less than or equals to minus 1. Now this graph, this curve, as you can see over here, this curve is also repeating after the interval of 2 pi. That means cosec x also repeat its value after the interval of 2 pi. Therefore, we write cosec 2 pi plus x is equals to cosec x. So, with the help of this graph information, we can find out which value repeats after which interval. Like as we have seen, sin x and cos x, they repeat their value after the interval of 2 pi, but tan x repeats its value after the interval of pi. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.